Hello students, myself Purva Joshi, Assistant Professor at LJ Institute of Engineering and Technology. Today we will discuss application of partial derivatives. So let's begin with the first topic, that is local extreme values. We can also call it maxima and minima. So let's begin with the method. If u is equals to f of xy is given, then apply the following step to find the extreme values. So the first step is we have to find P, Q, R, S and T. So what is P? P is Fx. Fx means what? Del F by del X. Q is Fy, that is del F by del Y, means derivative of F with respect to Y. Next one, R is Fxx, that is del square F by del X square. S is Fxy, that is del square F by del X del Y, and T, that is Fyy, so del square F by del Y square. So in the first step we have to find this P, Q, R, S and T. Next one. Next we will find stationary points by taking P is equal to 0 and Q is equal to 0. Okay, so we have to take this to equal to 0. We have to solve this two equation to get stationary points. Next, we will find R, S and T at this particular point AB. Okay, and then we will find this RT minus S square. Now, on depending on this RT minus S square, we will get the conclusion. So, firstly, if RT minus S square is greater than 0, then there arise two possibility for R greater than 0 and for R less than 0. Okay, so whenever we have R greater than 0, you will get minimum value at this particular point AB. If you have R less than 0, then you will get maximum value at this particular point AB. So first step should be this RT minus S square should be greater than 0 to get extreme values. Okay, next one, if RT minus S square is less than 0, okay, then we can say that this point AB are saddle points. Okay, means F attains both maxima and minimum value at AB. And if RT minus S square is equal to 0, then no conclusion can be made about extreme values. Okay, so we have to check in different way. Next one, example is find maxima and minima of x cube plus 3xy square minus 3x square minus 3y square plus 7. So let's begin with the solution. Firstly, f of xy is given, that is x cube plus 3xy square minus 3x square minus 3y square plus 7. So first step is to find p, that is fx, means partial derivative of f with respect to x. Okay, so differentiate this equation with respect to x. So from this you will get 3x square. Here we have to keep y constant. So from this you will get 3y square. From this you will get minus 6x and y constant. So this derivative is 0. 7 is also constant. So derivative is 0. Okay, so we have p is equal to fx, that is 3x square plus 3y square minus 6x. Q, that is fy. Okay, so differentiate this with respect to y. So this term is 0. From here you will get 6xy, right? The derivative of this term is 0 because x is constant now. Derivative of this term is 6y. So here we have minus 6y and derivative of 7 is 0. Next we will find r, that is del square f by del x square. So this is what del by del x of del f by del x. Okay, so firstly we have to this we have del f by del x. Okay, so now differentiate this with respect to x. So differentiate, so here you will get 6x, this term is 0 and from this you will get minus 6. Next, s is fxy, that is del square f by del x del y. Okay, so this is what del by del x of del f by del y. Okay, so you have to differentiate this del f by del y, that is this fy with respect to x. So you will get 6y. Next one t, that is fyy, means del square f by del y square. So this is del by del y of del f by del y. Okay, so you have this answer of del f by del y, this fy. Okay, so differentiate this with respect to y. So you will get answer as 6x minus 6. Next step. Step 2 is to find p is equal to 0 and q is equal to 0. We have to take this. Okay, so just take both equals to 0. So you will get 3x square plus 3y square minus 6x is equal to 0. And from here you will get 6xy minus 6y is equal to 0. Now take 6y common. So you will get 6y into x minus 1 is equal to 0. So from this you will get y is equal to 0 and x is equal to 1. Okay, now we will substitute this in this equation. Okay, so firstly take y is equal to 0 and substitute y is equal to 0 in this. So from this you will get 3x square minus 6x is equal to 0. Take 3x common. So 3x into x minus 2 is equal to 0. So from this you will get x is equal to 0 and x is equal to 2. Now we will write stationary point. Here x is 0 and y is 0. So first point is 0, 0. Next, x is 2 and y is 0. So another point is 2, 0. Okay, so these both the points are known as stationary points. Now we will substitute x is equal to 1 in that equation. Okay, so on substituting you will get 3y square minus 3 is equal to 0. Take 3 common. So 3 into y square minus 1 is equal to 0. So you will get y as plus or minus 1. Now take x is equal to 1 and y 1 first. So you will get 1 point, that is 1 comma 1. Then x is equal to 1 and y minus 1. So you will get another point, that is 1 minus 1. Okay, so these 2 points are also stationary points. So in all we had total 4 points, that is 0, 0, 1, 1, 1 minus 1 and 2 comma 0, which are stationary points. Now step 3. So you have to make such tables. Okay, so in first we have to write the points. So in all we had 4 points. So write down that 4.00, 20, 11 and 1 minus 1. Then we have to write r, s and t. R is 6x minus 6, s is 6y and t is 6x minus 6. Okay, and then we have to write this rt minus s square. Okay, so first simplify this for this particular point 0, 0. Okay, so here in place of x write down 0. So you will get minus 6. Okay, then here in place of y write down 0. So you will get 0. Again in place of x 0. So you will get answer minus 6. Now we have to find this rt minus s square. Okay, now multiply r and t. So you will get 36 minus s square. So 0. So 36 greater than 0. Next one, we have to find RST at this particular point 2, 0. Okay, so in place of x substitute 2. So you will get here 6. Next, in place of y substitute 0. So you will get 0. Again in place of x substitute 2. So you will get 6. Then find RT minus s square. So you will get 36. Similarly, we have to solve for 1, 1 and for 1 minus 1. Okay, so you will get these values and you will get rt minus s square for 1, 1 as minus 36 and for 1 minus 1 also minus 36. Now we have to check this rt minus s square. Okay, so this is greater than 0. So now we have to check r. Now here r is what? Minus 6, which is less than 0. Therefore this 0, 0 is maximum point. So you will get maximum value at this particular point 0, 0. Okay, and also we have to find the maximum value. So in the question, in place of x and y you have to substitute 0, 0. So you will get the value of f maximum, that is 7. Again we have rt minus s square greater than 0 at this particular point 2, 0. So now check r. Now r is 6, that is greater than 0. Okay, so when r is greater than 0 we have minimum value. Okay, so we get minimum value at this point 2, 0. Okay, so f minimum at 2, 0 is 3. So in question, in place of x, you have to substitute 2, and in place of y, 0, and simplify. So you will get answer 3. Now this rt minus s square is less than 0, that is minus 36 at 0.11 and 1 minus 1. So these both the points are known as saddle points. Next example. Find the maxima and minima of x cube plus 3xy square minus 15x square minus 15y square plus 72x. Okay, so let's begin with the first step. So first step is to find p, that is fx. So differentiate this function with respect to x. So you will get 3x square plus, from this you will get 3y square, from this you will get minus 30x. This term is 0, and from this you will get 72. Okay, next we will find q, that is fy. So differentiate this function with respect to y, keeping x constant. So this term is 0, and from this you will get 6xy. This term is 0, from here you will get minus 30y. Okay, next we have to find r. R is what? Fxx. Okay, so that is del square f by del x square, means del by del x of del f by del x. Del f by del x means fx. We have this answer. Okay, so differentiate this with respect to x. So you will get here 6x minus 30. Next, we have to find s, that is fxy. So this is del square f by del x del y. So this is del by del x of del f by del y. We have this answer of del f by del y, that is fy. So differentiate this with respect to x. So you will get answer 6y. Next, we have to find t, that is fyy. So this is del square f by del y square. So this is del by del y of del f by del y. So now differentiate this function fy with respect to y. So you will get answer 6x minus 30. Okay, now let's begin with step 2. So here we have to take p is equal to 0, q is equal to 0. So you will get 3x square plus 3y square minus 30x plus 72 equals to 0, and 6xy minus 30y equal to 0. Now first we will simplify this. Okay, take 6y common. So you will get 6y into x minus 5 equal to 0. So from this you will get y is equal to 0 and x is equal to 5. So firstly we will take y is equal to 0 and we will substitute this y is equal to 0 in this equation. So this term is gone. So what remains is 3x square minus 30x plus 72. Simplify this. Okay, and we have to find the factors of this. So you will get 3 into x minus 6 into x minus 4 is equal to 0. From this you will get the value of x is equal to 4 and 6. Now here we have x as a 4 and y 0. So points will be 4, 0. X as a 6 and y 0. So you will get 6, 0 as stationary point. Next, we will take x is equal to 5 and substitute in that equation. So you will get 3y square minus 3 is equal to 0. Take 3 common. So from this you will get y is equal to plus or minus 1. Now we have x 5 and y 1. So first point 5 1, x 5 and y minus 1. So another point it is 5 minus 1. So these two points are stationary points. Next, so in all we had 4 points, that is 4 0, 6 0, 5 1 and 5 minus 1. These are stationary points. Now we will make a table. Okay, so first we have to write these points AB. So points are 4 0, 6 0, 5 1 and 5 minus 1. First we write down these 4 points. Then R. R is what? 6x minus 30. S 6y and T 6x minus 30. Now in place of x you have to write 4. Okay, so we are solving for 4 comma 0. So in place of x write down 4. So you will get 24 minus 30, that is minus 6. Okay, now in place of y write down 0. So you will get 0. Again in place of x 4. So you will get minus 6. Now we have to find rt minus s square. Okay, so multiply this r and t. So you will get here 36. Next, we have to solve for this point 6 comma 0. Okay, so again in place of x you have to substitute 6 and in place of y we have to substitute 0. Okay, so you will get here 36 minus 30. So 6, as in s you will get 0 and again t you will get 6. Find rt minus s square. So you will get 36. Next we will solve for 5 1. So again in place of x we have to substitute 5. So you will get 30 minus 30. So answer is 0. In place of y substitute 1. So you will get 6. Again you will get t 0. So our t minus I square, it will be 0 minus 36. So it will be minus 36. Next we have to solve for f minus 1. So we will get the answer as 0 minus 6 and 0. Again we have to find rt minus s square. Okay, so it will be 0 minus again minus 6 whole square. So that is minus 36. Now we have to see this rt minus s square is greater than 0 for these two terms. Okay, so firstly let's see for this. So we have to check r. Now r is minus 6, that is less than 0. So whenever we have r less than 0, so we will get f maximum at which point? 4 comma 0. Okay, so we will get f max at 4 comma 0 and which is 112. So to get this value we have to substitute 4 comma 0 in the question in the fxy. Okay, so you will get this answer 112. Next, rt minus s square is again 36, which is greater than 0 for which point? 6 comma 0. So we will check r. So again here r is greater than 0. Okay, so whenever we have r greater than 0, so we will get minimum value. So we will get minimum value at point 6 comma 0. Okay, so in the question in place of x you have to substitute 6 and in place of y you have to substitute 0 and simplify to get the answer 108. Now rt minus s square is less than 0 for these 2 points, that is 5 1 and 5 minus 1. So these 2 points are known as saddle points. Okay, so now let's discuss what we have studied in today's session. So firstly, to find extreme values, what we have to do, the first step is to find p, q, r, s and t. What is p? P is fx, q, fy, r, fxx, s is fxy and t fyy. Okay, so first we have to solve this. Next we have to equate p equals to 0 and q equals to 0. On equating you will get two equations and on solving this you will get points. Okay, so these points are stationary points. Then what we have to do, then we have to find rt minus s square. Okay, so for that we will make a table. Okay, so in table first we will write ab, then r, then s and t, and then we will write rt minus s square and lastly conclusion. Okay, so first we have to write down all the points and the value of r, s and t, and we have to find the value at all the points. Okay, and now the condition of this rt minus s square arrives. Okay, so if rt minus s square is greater than 0, we have two possibilities. Either the function is maximum or minimum. We will get maximum answer for r less than 0 and minimum for r greater than 0. Okay, and if this rt minus s square is less than 0, then we can say the points are saddle points. Okay, and if rt minus s square is equal to 0, then no conclusion. I hope you have understood. Thank you for watching.